Welcome. In this lecture, I'd like to introduce inverse functions, which is one of these things that it gets a little bit confusing because the notation indicates sometimes something that it's not. So pay very careful attention to what I'm saying, and you'll see examples so you get a better idea of what exactly I mean. But an inverse function is going to be a particular kind of function, and it's going to be defined in a way that I'll show you. Okay, so here's the notation for it. So I'm going to write like this. Okay, so when I write this, this is used to mean the inverse function. So this is used to mean the inverse function of f. So this is the inverse function of, and then we're going to have this function f. So once I'm given a function f, I'm going to get another function, which is going to be called the inverse of this. Okay, and the caution, so I said there was going to be a caution here that gets a bit confusing to students. So the caution is that f inverse does not mean that we're taking 1 divided by f, okay? So sometimes you'll want to think that, because we do that, you know, for 1/3, I would write 3 to the negative power. But this is a little bit different notation. It actually, in some sense, comes from the same place, but it's with like a collection of functions that you're talking about instead. Okay, so this is going to be the function inverse. And here's kind of like a hand-wavy description of what it is. So here's some hand waving, as one might say. Okay, so f inverse is going to undo. So f inverse undoes whatever f did. So it undoes whatever f did. Okay, so how does this end up working? It ends up meaning that if I happen to have that f inverse of x, so if when I put in x, it's an input into this function, I got out y. Okay, well, this would correspond to having that f of y equals x. So this is like having the f of y equals x. So it's kind of switching the inputs and the outputs. Okay, and then the same kind of thing is that, you know, we don't really care about what this symbol is. It's still the same relationship. So you're going to have that f inverse of, what if the symbol I inputted is y? And what I outputted was x, like this. Then I would swap in the same sense. And I would get that f, now I would have that f of y is going to equal x. Sorry, f of x is going to equal y. Okay, so it's swapping the input and the output. And just to kind of emphasize, because this gets a little confusing to people, when both functions are kind of written where x is the variable, is to just replace the variable with something ridiculous like a star. And, you know, then the corresponding output with maybe a heart. Then this, it's the same deal where you would have then of f of heart equals star. It's just that the inputs and the outputs are going to get swapped. In particular, what's going to happen is that if I wanted to figure out, how do I figure out what f inverse of 2 is, I look at the function f, I look at what input gives me 2, and then that becomes my output for f inverse. Okay, and we'll kind of go through this kind of thing. And then also, so here's also. We have that f inverse of, so f inverse of f of, and then if I have x here, I'm going to get out x. And if I take f of f inverse of x, I'm going to get out x. Okay, so the other thing that happens, and this is the sense in which they undo each other, really, which is that if I apply the function f to some input, and then I apply f inverse, I'm actually going to get out that original input. And the same thing works in the other direction, whereas if I have an input x, I apply f inverse to it, and then I apply f to it, I actually get out that same input x. Okay, so hope that made a little sense, and if not, hopefully in the examples it'll make more sense. And I will see you in the next lecture.